In this video, we're going to now continue our review of the 5th grade curriculum. In part 1, we looked at number theory, and now we're going to look at decimals. We're going to talk about where the word decimal comes from. We're going to talk about place values, rounding in decimals. We're going to skip this, and then we're going to talk about converting fractions into decimals. Okay, the word decimal has the root deci. Folks, that means 10. For example, a decade. Oops. A decade is how many years? 10 years. A decathlon has how many events? 10 events. I don't remember what they are. I think there's pole vaulting, mile run, shot put, etc. I'm embarrassed. I don't know what all 10 of them are. But whenever you see deca or deci, think about 10. Now, why is that important? When you're dealing with decimals, folks, each movement represents a power of 10. For example, if I take the number 7, now we don't always put it there, but there's a hidden decimal here and a hidden 0 here. In other words, these two configurations of the number 7 are technically correct. This is called the decimal point. Each time we move the decimal point, the number 10 is going to be involved. For example, if some person comes into our classroom, takes this decimal point, and moves it one space this way, this number 7 has now become the number 70. And what do we notice? 7 times 10 gives us 70. Alternatively, the person that came into our room could have taken that decimal point, which recall was here initially, and he or she could have moved the decimal point this way. Now we have the number 0.70. We don't have to put that 0 there, so I'm going to take it away. 0.7, and we know that to be 7/10. So depending on where you move the decimal point, let me rephrase that. Depending on which way you move the decimal point, you're either going to get bigger or smaller. The first time we moved it to the right, we got bigger. We went to 70 by a power of 10. Here, we went from 7 to 0.7. We decreased by a power of 10. Everything with decimals has to do with moving the decimal point and figuring out whether the number is getting larger or bigger by a power of 10. Let's talk now about decimal places. If I wrote this number down, I don't like that one. If I wrote this number down, folks, this is the ones place of the whole number. But when we move past our decimal point, which is right here, this is our tenths, this is our hundredths, this is our thousandths, I think that's spelled right. Well, maybe there's no D in there, not sure. Okay. Decimal place, as you move to the right in a decimal place, tenths, hundredths, thousandths. Here, this is part of a whole number. There's the ones position. If I were to add the number 1, that would be the tens position. Okay. I'm going to write some numbers down, and I'd like you to tell me about place value. If I wrote down 653.108, this 1 would be in the hundredths position. Decimal point, tenths, hundredths, thousandths. Okay, I'd like you to pause the video as I write these down. I'd like you to tell me which place is the 7 in. Answer is in the ones. Here's our decimal place. Going to the right, tenths, hundredths, thousandths. Here on the side of the whole number, ones, tens. So 7 would be in the ones position. I'm going to write some down. I'd like you to pause the video and quiz yourself. Okay, I assume that you had a go on this. What place is this 4 in? That would be the tenths place. Let me write that down. What is the tenths place in this number here? It would be 1. What is the tens place in this number here? It would be the 4. Okay, folks, now we're going to talk about rounding numbers. Okay. Rounding numbers, the key number is 5. Let me tell you what I mean by that. If we have the number 4.6, and we're deciding whether to round it down to the nearest whole number, which is 4, or up to the nearest whole number, which is 5, the answer is going to be raise it up to 5. The reason is this number is larger than 5. Another one. If I asked you to round this number to the nearest whole number, okay, here's the nearest whole number, would you go up to 4 or would you go down to 3? The answer is you would go down to 3 because the number next to it, this 3, is below 5. Let's do another one. If you had the number and I asked you to round this to the nearest tenths place, this is how you do it. They want it to the nearest tenths place. You go to the tenths place. Right here. You go to the number next to it and you ask yourself, is it equal to 5 or greater? If it is, you raise this number. So this becomes 53.3. another topic in math that is best done with examples. What is 50.44 to the nearest tenths? We go to the tenths place. We go to the number next door. If it's 5 or greater, we go up. If it's less than 5, we stay right where we are. That's your answer. We did not change this because the number next to it was less than 5. What would this number be? To the nearest hundredths. How do we do that? We go to the hundredths place. We look next door. If this number is 5 or larger, we raise this number. If it's less than 5, we keep it as is. It stays as is. What is to the nearest tenth? Place. We go to the tenths place. We go next door. If it's larger than 5 or larger, I should say, we make it bigger. There's your answer. How about this one in red? What is 23.87 to the nearest tenth? And then a second version, I want the nearest whole number. Let's do the nearest tenth first. We go to the tenths place. Then we go next door. If it's 5 or bigger, we go up. The answer to this is 23.9. Nearest whole number. We go to the whole number. We go next door. If that number is 5 or larger, we raise the whole number. That's your answer. Okay, folks, let's see what's next on our list. We're now going to convert fractions to decimals. Okay? Folks, fractions and decimals are different ways to say the same thing. If I said 5 plus 2, that's a different way to say 7. It turns out I can say 0.5, or I could say 1/2, or I could say 5/10. These are all the same value. They look different, just like 5 plus 2 looks different than 7, but they have the same value. And how do we know that? Because there's an equal sign. So in essence, when you have a decimal, you have a fraction. It just looks different. Same value though. Okay, let's look at some decimals and convert them to fractions. Folks, how would you pronounce that in words? What you would say is, that is 41 hundredths. Well, so is this. It's almost the easiest way to do it. Pronounce the word and then create the fraction. So the denominator of the fraction is going to be the place value furthest to the right. What would this be? What is the place value furthest to the right? Tenths. Tenths. Therefore, 10 is going to go in the denominator. Pronounce this number here would be 7/10. How would you pronounce this? You would pronounce this as 73/100ths. The place value furthest to the right is hundredths. That goes in the denominator. 73/100ths. How about this one? The place value furthest to the right. Tenths, hundredths, thousandths. That goes in the denominator. 894 in the numerator. If someone was to read this out loud, he or she would say 894 thousandths. If someone was to say this fraction, he or she would say 894 thousandths. Okay, I'm going to write some down. I'll have you pause the video and try these on your own. Actually, we haven't done one with a whole number, so let me show you how to do that first. This would be 7 and 21/100ths. So when we get to the decimal, we use the word and. This would be 14 and 7/10ths, because it's in the tenths place. Okay, but this unit is actually about converting decimals to fractions. So let me just stick with that. I apologize, I digressed there a little bit. Okay, let's have you try these on your own. I'd like you to create the fraction. Hopefully you have some scrap paper. And these last two are a little bit difficult. Pause the video and see how you do. Okay, first one. Furthest to the right is hundredths. That goes in the denominator. 21 goes in the numerator. 21/100ths. Thousandths is furthest to the right. 365 in the numerator. Okay, this is a little bit more difficult. What is the furthest place value to the right? Tenths, hundredths. 100 goes in the denominator. 3 in the numerator. So we read this as 3/100ths. How about this one? Furthest place to the right. Tenths, hundredths, thousandths. Therefore, 1,000 goes in the denominator. 16's in the numerator. 16 thousandths. Okay. Let's see what's next. Okay, folks. So we did place value, we rounded, we converted fractions to decimals. Now we're going to talk about how to multiply decimals. Multiply a decimal by a power of 10. Very important. Folks, when you multiply any number by 10, it gets bigger. Okay? If I multiply 2 times 10, this 2 becomes 20. It went from 2, and when you multiplied by 10, it got bigger. Take any number. If you take 8 and multiply it by 10, it becomes 80. Gets bigger. Same thing when you multiply by another power of 10. What about 4 times 100? What is that? 400. The 4 got bigger. And how much bigger did it get? It got bigger by 2 zeros. If you multiply by 100, the number in question is going to get bigger by 2 zeros, 2 decimal places. Okay, let's talk about that. If I give you this number, and I multiply that number by 10, is this number going to get bigger or smaller? The answer is bigger. How much bigger is it going to get? It's going to get bigger by 1 decimal place. So what we're going to do is we're going to take this decimal place and move it this way, 1 spot. Why do we move it this way? Because if we move it this way, the number becomes 143, bigger than 14.3. If we were to, by mistake, move it this way, we would get 1.43. We know that can't be correct because we got smaller. So if you're multiplying, the movement of your decimal place has to result in a bigger number. How much bigger? The number of zeros will tell you that. Let's do another one. Let's multiply we're multiplying. I don't like that X, I like the dot. So let me take that away. We're multiplying. Here's our number in the box that we're starting with. Folks, is this number, when we multiply by 100, going to get bigger or smaller? Has to get bigger. How much bigger does it get? It gets bigger by 2 decimal places. So we are going to move it this way. 1, 2. Final answer. If you want to put an extra 0, you can. It's a freebie, you don't have to do that. Start it out with 12.97. We're multiplying by 100, it gets bigger. Someone in class raises their hand and says, okay, how did you know not to move it left by 2 places? Well, if we moved it left by 2 places and put the decimal place there, it would have become 0.1297. It would have went from 12.97 originally, move it 2 places to this number. Can't do that. It's smaller. This is 1,297 10,000ths. Okay, that's the 10,000th place. That's the 1,000th, 100th, 10th. No way. Move the decimal place to make it bigger if you're multiplying. Okay, let's do some examples. What is 7 times 10? Okay, our number in the box is 7, technically 7.0. Is it going to get bigger or smaller? It's going to get bigger by how much? 1 decimal place. We're going to move this to the right 1 decimal place and get 70. What is again, I don't like that X. I don't know why I keep doing it. Okay, here's our number in the box. We're multiplying by 100. Our final answer has to be bigger. How much bigger? 2 decimal places bigger because there's 2 zeros. I'm going to take this decimal place. We're going to move it to the right such that it makes the number bigger. 1, 2. It's going to go right there. Final answer. Okay. Folks, one thing I want to show you is the concept of moving a decimal place into blank space. I don't like that. Let's look at an example. If I gave you 3.9 times 1,000 equals, we know that this decimal place has to be moved so as to make this number bigger. That means we're going to go to the right. How far to the right? 3 decimal places. So let's do that. Let's take this decimal place and move it 3 spots to the right. 1, 2, 3. Okay, now what? Where do we put our zeros here? And how many are there? Is it this? Like that? Is it like this? We don't know. Because we moved that decimal place into blank space. Look at that. To me, that's a mistake. If you move this decimal place into this Never Never Land, you're going to get lost. You're not going to know how many zeros to put. So this is what I like to do. Let's get that decimal place back where it was. Oops. And before we move it to the right, I'm going to put in some phantom zeros in. I'm going to give myself a place to put the decimal place. And if I have a couple extra zeros here, that's okay. So now when I move this 3 decimal places to the right, I have a place to put it. 1, 2, 3. Right there. Okay, started here. 1, 2, 3. Specific spots to put it, as opposed to Never Never Land. Okay, here's our final answer. 3,900. If you want to put the decimal place 0.0, you can. You do not have to. Folks, what is this? I'd like you to pause the video and try these on your own piece of paper. Okay. Let's go. Multiplying by a big number, we're going to get bigger. How much bigger? 4 zeros bigger. We know we have to move this decimal place 4 places to the left. But if we do, we're going to be in Never Never Land. Let me show you what I mean. I'm going to put some phantom zeros here. So now, when I take this decimal place and I move it 4 places to the right, 1, 2, 3, 4, it's going to go right there. 1, 2, 3, 4. This is my final answer. How about this one? We're going to get bigger. we know we're going to be moving this to the right 2 decimal places. I want some phantom zeros in there to guide me where to put it. Okay, we start here. We're going to move 2 places, 1, 2, and this is our final answer. 8, 5, 7. Okay. Last topic for this video is multiplying decimals. If I multiply 8 times 5, that's 40. Done. However, if I have a decimal place, we are not done. What we do is we do our normal multiplication, and then we account for this decimal place. We know these answers have to be different. You can't have 8 times 5 equals 40 and 0.8 times 5 equals 40. That makes no sense. So how do we handle this decimal place? What we do is we look at the entire problem and we say, okay, how many digits are to the right of the decimal place total? And we put a check mark. 1. There is no decimal place here. Or if there was, let's say this is 5.0, you can ignore this, as long as that's a 0 after the decimal place. So in that scenario, when there's 1 check mark, we take the decimal place, which normally is after the 40, and we move it 1 spot to the left. For every check mark there is, that's how many spots you move it to the left. So this becomes 4. Not 40, but 4. Let's do another one. Here we have 0.1 times 0.8. What I recommend in this scenario is you do your normal multiplication. 8 times 1 is 8. 8 times 0 is 0. You put a 0 placeholder. 0 times 1 is 0. 0 times 0 is 0. You add them. You get 8, 0, and 0. You can forget about these 2 zeros. That is temporarily your final answer. Now, you got to deal with the decimal place. The decimal place starts here. Because of these decimals up here, we're going to have to move it. How many places do we move it to the left? 1, 2. There are 2 digits located to the right of the decimal place in the entire complex. So we're going to go this way 2 places. But look, folks, we're going into Never Never Land here again. So let's, before we move, let's put our placeholder zeros here. Now let's move 2 places. 1, 2. That's our final answer, 0.08. Okay. How would you handle this one? Personally, I would just do the multiplication and not even worry about the decimal places at first. Okay, so let's do that. Let's align these up a little better. Like so. Okay. 4 times 8 is 32. Whoops. Should be 2. 3 on top. 4 times 9 is 36, plus 3 is 39. Put down the 0. 0 times 8 is 0. 0 times 9 is 0. We add them. 2, 9, and 3. Now, we go up top. How many digits are located on this side of the decimal place total? 1, 2, 3. We take our decimal place and we move it 1, 2, 3. Final answer. Let's try one more on your own. Please pause the video. What is 9.63 times 0.1? Again, I like to realign this. It helps me. I'm going to ignore the decimal places. 1 times 3 is 3. 1 times 6 is 6. 1 times 9 is 9. Placeholder 0. 0 times 3 is 0. 0 times 6 is 0. 0 times 9 is 0. Add them. Now I'm going to address my decimal place. I have 1, 2, 3 digits located on this side of the decimal. Therefore, I'm going to move this 1, 2, 3. Final answer is 0.96.